This is the MeatEater podcast coming at you shirtless, severely bug-bitten, and in my case, underwearless.
We hunt the MeatEater podcast.
You can't predict anything.
The MeatEater podcast is brought to you by First Light. Whether you're checking trail cams, hanging deer stands, or scouting for elk, First Light has performance apparel to support every hunter in every environment. Check it out at firstlight.com. FIRSTLITE.com. Brody, they're going to do, we've talked about this in the past. Mm-hmm. It's looking more and more likely that Colorado will have a wolverine reintroduction.
It's in the works for sure. At the same time, this whole ESA thing is going on. Colorado has approved a reintroduction. I don't think it's going to happen overnight. But it's the plans are in the works. They got to go through some hoops to get it done. And like you said, you know, they belong there. It's a native species, right?
Yeah, I'd like to see it happen. I'm not a fan of who's doing it, but I like to see it happen.
Right.
Like if someone you don't like gave you $500, it's still $500.
So how's that fall in line with your feelings on them being listed?
I don't think that I just don't see that they should have been listed here.
Because there's never a lot of them in the first place.
Yeah. It's like there's just not a lot of historic data of what they were going on. They're largely going on some findings from BC, extrapolating that will happen here. It's like a future.
Right.
It's like a future listing. It's like, well, I could see there being problems in the future based on gut. Therefore,
mm-hmm.
And then I also know how to be leveraged. Like I already know how to be leveraged.
Yeah, well,
I think it's a proxy fight.
Yeah, and that leverage is the same concern I have. Like, I'm all for the reintroduction in Colorado.
Where are they pulling wolverines from? Like, where did they determine the
so
population is so robust? Right? Because it can't be a pen raise.
A couple out in the barn.
Right.
You know
They
how
probably
that
haven't
ends
even thought about that yet.
But yeah, I don't think they've gotten that far
Okay.
yet. They didn't put a lot of thought into the wolf reintroduction.
But they eventually got them.
Yeah, they got them.
They'll get them.
But the leverage you're worried about is the same leverage I'm worried about with an administration like the Putelis administration, like leveraging that against hunting, against trapping, being like, oh, this area is closed now. You can't go in there.
Yeah.
It's a refuge for an endangered
Right.
species,
Right.
which means we're going to prohibit human travel or
Whatever.
trapping or anything that could conceivably
Yep.
harm that species.
Yeah. I mean, that administration has made it clear that that's their angle. So we'll see
Yeah,
what
I think
happens.
it'll be. It's like I fear that it become a proxy
Mhm.
thing where they're like what's happening here is they're kind of talking about wolverines, but they're kind of not.
Yeah.
They're talking about backcountry travel.
Yep.
Right. They're talking about snowmobile use, trapping restrictions.
Yeah, I mean, it's kind of like you've talked about it before, the lynx thing here. Like, there's lynx up in northwestern Montana, but down here in southwestern Montana, where there's not really there's this low elevation habitat that's like potential lynx habitat where you can't trap bobcats. Like,
Yeah.
I could see some version of that happening down in Colorado. I don't know.
Yeah. They drew it with a. They drew the lines. What's the thing I'm looking for? Like, not surgically.
Right.
Like the lynx recovery area wound up including a lot of stuff that never has
never will.
had, and never will have a lynx.
Yeah.
But I think there's work on that being done. I don't know if it'll be applied,
Right.
but
For the wolverines, though, like those boundary lines of wolverine habitat, right, should be like pretty close proximity to like permanent snow fields, glacial areas.
a convenience store in Washington State.
Downtown Lewiston, Montana.
Right.
Downtown.
Yeah. Well, they like to walk, you know?
Yeah.
Yeah.
What spurred a lot of this, I recently got a trail cam photo of a wolverine, which is
Oh,
cool.
sweet.
You haven't seen that?
No.
Dude. I got a camera hanging on one tree.
Did you put a set right there by the camera?
No. I got a camera hanging on a tree, and on that camera I've gotten gray wolves, coyote, red fox, bobcat, mountain lion, black bear, now wolverine, marten, long-tailed weasel.
A lot of predators, man.
I'm waiting for a grizzly and a lynx to walk
That's
past.
amazing.
That's cool.
Yeah.
All same freaking tree.
That's really cool.
They like that tree.
And I had that Wolverine came through. So I posted that picture and generated a lot of discussion. I posted the picture and used that occasion to gripe about the move to threatened and how the state of Montana is suing against it. And then a guy wrote in what I thought was going to be a guy wrote in where he starts out pretty good attacking my position, but then he lost all credibility with me because in the end he uses discrete population segment when instead in fact it's distinct population segment. And I'm like, this guy doesn't have any idea what he's talking about. He even capitalized it. So he doesn't know what a DPS is. So out the door.
Sorry, man.
It was out the door with what he
Better change your email before you're right back in.
It was out the door with what he thinks. No, a lot of people are griping about that, but I'm not giving an inch, dude. I'm not giving an inch on it.
Stick to your guns, man.
Like I don't. I'm a big time wilderness advocate. Big time.
Yep.
I pointed out in this thing, like I have come out all the time, like continued protections for Anwar in opposition to Ambler Road. We just did a podcast celebrating the Gila Wilderness Area and the creation of the wilderness system, which we've done a bunch of times. And it's like, don't come at me about it from that angle. In this case, I think the Wolverine thing is bullshit.
Well, obviously, we have a big issue with wildlife populations, right? When we talk about scientific management, which is a conversation we have all the time, right? It's like it can be used for good and bad from my perspective, where it's like, well, we don't know how many animals there are. So we need to figure that out, but then we can set our regulations. And it's like, but we never do know how many animals there are. Like we never will.
Yeah,
right?
When they started doing the population work on wolverines and when they started the population work on wolverines in Idaho, Montana, Wyoming, the biggest takeaway was, geez, there's wolverines all over the place. And all of a sudden out of that came this. I don't think it's a good use of time.
Well, and there's always a focus on did it exist?
I haven't introduced you yet.
I'm just going to jump in because
you're going to talk before introduction.
No, you're going to talk.
I thought we were going to shut him.
You're going to talk for 2 hours.
I didn't know we had such formal rules here.
No, please get started.
There's always this focus on where had it existed in there, and there's usually little focus on what did it perform for the ecosystem, what good does it do back to the ecosystem. And I think that's where the narrative needs to be going, not historically where did it range, and because we're usually taking snapshots that could be completely out of context for why the animals were pushed into a certain area, but we need to be focused on how do we bring species back into ecosystems that perform specific functions to improve biodiversity, to improve ecosystem health, and be less focused on did it exist there one day 250 years ago?
Or
did
500
it show up in
years from now,
Did it
somebody
show up in
goes,
Lewistown, Montana one day?
yeah, convenience store in Washington, right? Somebody's like, oh, look at the data. Like, I mean,
Yeah, it ranged in the dairy aisle, so we got to put it back.
That would be a datum. Is that?
Ladies and gentlemen, you just heard the voice of Matt James from Colossal Laboratories and Biosciences. I don't want to trivialize. Okay, I'm going to titillate people without trivializing what you do. Okay,
Should be interesting.
This is the company. These are the people leading the charge, with the most likely path forward on this idea, which we discussed before, of cloning a woolly mammoth, of resurrecting the Tasmanian tiger, of perhaps one day putting dodo birds back on the landscape. What was their island?
Mauritius.
Yeah. So we're going to talk about de-extinction. And again, when I said I don't want to trivialize it, because we're also going to talk about preventing extinction.
Exactly.
So a lot of emphasis in this world gets put on. In the news, it always gets like cloning a mammoth, cloning a mammoth, cloning a mammoth. But out of that work, and it's almost become shorthand for a collection of. It's become shorthand for like this a collection of technological advancements that are applicable around biodiversity and applicable around preventing extinction, and then if need be, de-extinction.
Exactly. De-extinction is sort of the intersection of this amazing set of technologies that are all emerging at a similar time. And we sit at that intersection today, which has given us the ability to not exactly clone a woolly mammoth. Right? We know we cannot do that. I think you had Beth Shapiro on years ago, and she talked about this problem exactly. But to be able to engineer genomes to begin to mirror extinct species and bring that species back in a way that is as representative of the extinct animal as it could be.
And what we talked about last night, maybe I'm going to have you start with this real quick, because this is not going to be the focus of our conversation. But let's say a fella had a once-in-a-lifetime hunting dog.
Let's say that. Yeah.
Okay. Let's say this. Yanni has a beloved dog, and it fell off a cliff recently. It's fine.
That's a real story?
That's true.
I'm sorry.
Okay. Let's say that Yanni's dog had fallen off that cliff and wasn't okay. Can you quickly walk through how he might wind up with, it's possible now.
Yep.
It's expensive, but possible, how he might wind up with that dog all over again.
Well, I mean, this kind of goes back to the late 90s when we talked about Dolly the sheep and cloning, right? This is just basic cloning technology, and de-extinction is an advancement thereof. But so for this example, we're really talking about cloning. So whether you had a living dog or a dog that, unfortunately just passed away.
Fresh dead.
Yeah, unfortunately, I hate to say it that way, but you need a fresh dead animal or a living animal, and you can extract living cells either from skin tissue, or there's even some novel technologies that might include being able to do this from blood. And what you do is you take those cells or those tissues and you put them into a petri dish, essentially, right? You're going to culture this, and you find out what are the culture conditions so that we can begin to take that one tissue and proliferate into this living cell line. And then we go and select very specific cells. We're going to look for things like epithelial cells, and we can make something called a fibroblast line. Once you have that, we just freeze it. You put it on liquid nitrogen. It'll live forever in a biobank. Excuse me. And
so Mingus is in a biobank.
Now Mingus is on ice in a biobank. And one day you say, I really want to see Mingus again. We have the ability to be able to go back to Mingus, take his cells, put them into the oocyte or the egg of a dog, and fertilize an embryo, culture that embryo in vitro, and then eventually transfer it into a surrogate dog. That surrogate would gestate 65 days later. Little day zero Mingus is born, and it is an exact living replica of the dog or whatever animal you were looking for. Now, obviously, there's
with a crazy bloodlust, right?
There's one thing that I think is always important with cloning is we have to talk about nature versus nurture, right? Your dog might not end up being, Mingus 2.0 might not be Mingus 1.0 because the way you raised the two might vary. And that plays a big role, especially in hunting dogs, as you guys know well better than I do. That training that happens really early on, that sort of life experience is as important as genetics often.
Well, dog-wise, right, like the way I was able to train a dog 10 years ago is a lot different than the way I was able to train a dog 2 years ago. So, like, that
because you changed.
Because I changed.
Because you've improved as a trainer.
Changed. Right? No, I'm way busier now.
Oh, so you're actually much worse at this.
So I'm way worse. Way worse. Yeah.
On that thing, like the nature versus nurture thing, but on this idea that pretty soon you would be able to just get your best hunting dogs cloned.
Mm-hmm.
And instead of just going back to the same sire, the same bitch, and getting another dog out of that litter, you're going to wind up with something closer, right?
Because every time you breed, you're sort of shuffling genetics, and the sire and the bitch's DNA will mix, and you'll get a different set of phenotypes than you might have just from the original. Just like you might have siblings that are not exactly the same as you. It's because it was a reshuffling of the genomic information. By cloning, you're actually taking that full genome and just doing it again.
Like how much would it look like? How much would Mingus 2.0 look like Mingus?
Are the spots in the same place?
So yeah, if it's a spotted
exactly,
dog.
right?
So this is a great question because there are several things that control the way that our genes are expressed into phenotypes, right? So one of them is obviously the genetics. What are the genetics telling the cells to make? But the other is a process called epigenetics. So basically, what are the environmental forces and around the expression of those genes? There's regulatory pathways. Maybe, say you were supposed to be 6'4", but you were undernourished as a child. You're not going to grow to be 6'4". That's an epigenetic effect, right? So you could clone 3 Minguses right now, and each of them would show up and look very, very similar. But those spots might end up in slightly different sizes or areas, and sometimes you see that drift. There's they've been cloning not racehorses, sorry, but like polo horses and dressage and horses like that. And you can go into a barn and you can see, a lot of these sort of brown horses with a nice white spot on their face, and it's slightly different on each one. It's the trippiest thing you've ever seen, yeah. But from afar, they are identical animals.
How much do you think you capture let's say you take Mingus, okay, and you give Mingus a stimuli, okay, like Mingus is, and I don't know if this is true or not, but Mingus is the sort of dog that if he gets up on the table, okay, and eats leftovers off the table when you're out of the room, and he's the kind of dog that, man, you tell him one time that ain't good, he ain't gonna do it again, right? Like, if that's a response to stimuli, what would you expect to see about the cloned dog's response to stimuli?
Well, it just depends on how it was raised. I would expect, that's really operant conditioning, right? When we talk about sort of how can you show a stimuli and then get a required behavior and provide a consequence. Sometimes it's positive, like you fed the dog, you gave them a treat because they did what you wanted, and other times maybe you yelled at the dog and the dog ran off. So negative conditioning there, right? If they were raised the same way, I bet it'd be identical. But if one was raised by a really great dog trainer and the other by somebody who just let his dog feed off the table, those 2 Minguses would probably behave very differently.
Go in different directions, yeah.
Is there another version of this where you can put add-ons into Mingus 2.0? Like, let's say he had a weak bark.
What we're doing, right?
Like Janis wanted Janis wanted a Mingus with a stronger bark.
Yeah,
but
obviously we're not
now
enhancing.
You're getting into your special.
Set that one up
We're not
nicely.
enhancing that. We'd call those like genetic enhancements or something. We're not really doing that for dogs or for things. We're focused on the conservation side. But to that point, yes, you could say we want to confer a specific disease resistance to this animal, right? Distemper in dogs is an issue, and they found, like with wolves, if you see a black wolf, that's actually a sign that there's been dogs that have integrated into that dog's genetic line. But it also is closely correlated with a resistance to distemper, which dogs naturally.
Is that right?
Yeah. So if you see a black wolf, now it has to be a heterozygous.
You're looking at old dog DNA.
You're looking at old dog DNA. Yeah, wolves did not evolve the black
I've read
gene.
that. Yeah.
But it also is highly correlated with distemper resistance. So you could identify that gene and find a dog that doesn't have it, and using genetic editing tools, the most famous being CRISPR, you could drop that in there, and then reasonably when the dog's born, it will be resistant to distemper.
All right. Can we move on from the pet project?
Oh no, that was a warm up.
Yeah.
We're gonna do a couple things. Then we're gonna get into all the big crazy stuff.
Yeah, that's like your boutique making money on the side spinoff.
Wait, we're not even doing it, but it's. I think it's an easy example for people to understand.
Okay, let's close that conversation out with this. When you crystal ball it, do you picture in 10 years? Do you picture that becoming kind of how we're producing hunting dogs, how we're producing specialty dogs, how we're producing drug sniffing dogs, where you have these 1 in 100 attributes?
I think in maybe 10 years is too soon, just because there's some social acceptance. But in the working dog class, especially hunting dogs and say police dogs, absolutely.
Yeah, like the military is like, no, I want that.
Why would you?
I want
roll
a bunch
the
of those.
Yeah. If this is a business for you,
I don't want to go through thousands of dogs to find that.
Exactly. Right? If this is a business for you, you're going to find a way. How can we most efficiently produce reliably reproduce that phenotype? Absolutely. And the science is there today, and it'll just in 10 years' time be so scalable and cheaper that I think it'll be widely accepted.
I asked you yesterday to throw me a ballpark on what this Mingus project. Are you comfortable doing this?
Sure, yeah.
I said, like, give me a ballpark. Like, Yanni wants a new Mingus. What's he looking at? If you just put it at fair market,
75K. I think just because, and that's a number I just kind of pulled out, a roundabout number when we were talking
and
last
you were
night.
talking about cost.
That's at cost. Yeah.
That's not retail markup.
No, because there's just so many. Yeah, there are so many.
Retail markup, the sky's the limit.
Yeah.
I mean, just looking at the duck hunting world,
Mm-hmm.
like what guys will pay for a finished Labrador Retriever or a German Shorthair Pointer that somebody else has gone through the raising of with a good background, and that good background typically just means everybody thinks that the dogs coming out of this kennel are the best.
Yep.
I mean, you can put whatever price tag you want on
What
that. And there's
what
somebody
are
out
some
there.
numbers you heard for the people are paying for those
Basically
dogs?
anything under $250,000
Wow.
for the right person. Yeah.
Matt, I'm going to put you in an
mean,
awkward position.
Oh, great. Yeah.
I want to clarify. This is not what you do.
Correct.
It's not what your company does.
But I'm starting to get an idea here.
It's not what you do. It's not what your company does.
I've got
but
an
like,
idea.
Like lay out for just take a wild ass guess. Take a wild ass guess. Let's put it in this case. Like the military, they have dogs they use in combat operations, whatever, and they want to order like a whole bunch of these dogs. Like what would that be?
Oof. Wild ass guess. I mean, you just think
you know
about
what's
government
great?
spending. I think you could go north of $1 million or $2 million on them.
Think
Right, if you had the
of,
right animal.
Yeah, the right. Yeah.
Think of the falconry and racing pigeon world. Like sultans of
Oh yeah.
we're
Yeah.
into money that
Mhm.
like
I mean, we're dancing
Let's
around
change the
racehorses.
subject.
Yeah.
Let's change the
Yeah.
subject. We're going to talk about what Matt actually does and what Colossal
Yeah,
Biosciences.
disclaimer is everything before just now is
no,
hypothetical.
it's just going to be the price is right for animals. Okay, man.
All right, we're going to get into what he actually
Don't
does.
go over
Because what they're actually doing is fascinating. We're going to get into what they're actually doing in just 1 second here. That was just a little warm up. The kids podcast we keep talking about starts July 5th, right?
Mhm.
On this podcast feed. We've said it a bunch of times. How many are we making?
5.
We're making 5 kids podcasts. Whether we make number 6 depends on if your kids like it.
Yeah.
I can't say any plainer than that. Each episode of the kids podcast goes like this. They're quick. How long are they? What are they coming in at, Phil? 20?
15 to 20.
Okay, it's a 3-act structure. There's why it's the way it is, where we explain why something is the way it is. It could be, why are teddy bears called teddy bears? It could be, what is an anadromous fish? It could be, when you say nocturnal, what's the opposite? And is there a middle ground?
I like it.
Asking the
I
important
like it so
question.
far.
And yeah, there is. It's called crepuscular. Okay.
that's what you can
what
look
are
forward to.
other
Take
why-
that
what
topic
are other
off.
why it's the way it is that we're doing? Oh, what exactly did Daniel Boone and Davy Crockett do for a living? Why it's
That
the way it
too.
is. What exactly were they up to? Why does everybody know about those guys? What did they do for a living? Can you think of more why it's the way it is, or we just do them all?
I think you just listed all of them.
Okay.
So
why it's the way it is. I host why it's the way it is. And I tell your kid why it's the way it is. What's my credential? I've been telling my kids why it's the way it is for 14 years.
And everyone else.
So that's why that's my job. And then there's
Guess that critter.
Guess That Critter, which Corinne works on, but it's hosted by my lovely wife who hosts. She does the read on Guess That Critter, where we do we use animals that have the craziest vocalizations, the most varied, craziest vocalizations. And we play vocalizations, and then we start providing a bed of clues. The earlier your kid gets it, the smarter your kid is.
A new IQ test.
You'll be able to take that
Yep.
score to your Montessori school in the
Yep.
future.
And you'll also know whether you want to pull blood from that kid and send it to me. Then the final thing is kids trivia. And we
It's
bring in a bunch of
hilarious.
actual live kids. They record trivia.
Not genetically
Spoiler
modified
Not fresh
kids.
dead.
It's the Henderson, Putelis, and Rinella kids.
Yeah,
Plus some friends.
heavily staffed by
Familiar
our own children,
kids.
and then with some neighbors, stray neighborhood kids we've brought in.
Rampant
We
nepotism.
brought in my primary care providers' kids, didn't we?
Yep.
Just bring in some stray kids. They play trivia, but they play trivia in this way. Keeping how kids these days, there's no winners and losers. They're all winners. So what the kids do is they build a pot of money for conservation. Meaning it's a trivia show for kids, but every time any of the kids gets every right answer generates more revenue into the pot, which goes to a conservation organization that's a kids-focused conservation group or a kids-focused charity. And so they're building the pot. Meaning when you ask all 10 of them a question, it's not that some of them win and lose, it's that the right answers build a pot of money. So it's a cooperative effort.
There are weak links in the chain that I'm sure
Yeah,
reveal
let's name
themselves
them,
over
please.
time.
Yeah. Well, the fun part, Randall,
the
is
weak links are the little ones.
In terms of the nature versus nurture, host Spencer Newharth definitely has found some personality similarities between our colleagues and their children, and he chooses to point them out each time.
Like Brody's kids just quietly have the right answer.
Yeah, I mean, he definitely picked on Mabel, one of Yanni's daughters, for having a similar trait of seeing if anyone.
But
had
that was
changed
only
the answer
because
before
Mabel
the answer.
called him out, and I think he was
Yeah,
embarrassed by
yeah.
getting called out by a 10-year-old.
the video component is there's a tube that shoots out a marshmallow to the person with the right answer. And that's where it really cranks up visually.
If you don't feel like you know us well already from listening to us for hours every week, now you'll get like another layer of who we
That's
are
right.
because you're going to get to
That's right.
study who our kids are.
And those of
Kinda
us without
weird.
children will remain mysterious.
That's right.
Which was the point the whole time.
June 27th, tune in on YouTube for our latest experiment. Not latest, we don't do that many. Yeah, I guess we've done a few experiments. 2 days ago, we went out and made bull boats. So we went and got a bull boat, as you know, or maybe you don't, is a temporary use watercraft that can be made using nothing but the hide off of a buffalo. It's called a bull boat because you need a pretty good sized critter to make it. We used a couple roughly 1,000-pound bulls. I think 3-year-old.
3-year-old
bulls.
is what, yeah.
We have a friend at North Bridger Bison, Matt Scoglin, North Bridger Bison, he has a bison ranch. He's explained to me before his animals are born on his ranch and they die on his ranch. All grass fed, field harvested. And what you do is when you want to buy from him, you buy the animal, right? It's custom slaughter. You buy the animal, you're buying the meat on the animal. You don't go on a website and buy a cut of this, a cut of that. You go in and buy a percentage of an animal that's currently living on his ranch. He field harvests the animal. It's custom cut to your specifications. Anyhow, we got hides from him and made boats. And we made boats using nothing but native materials. So we went into a willow patch and used willow bark, which I didn't love, used willow bark, braided buffalo hair, which I didn't love, and cuts of rawhide thong, not thongs.
strips of
strips of rawhide for rope. So willows, willow bark, buffalo hair, strips of buffalo hide as rope, and crafted bull boats.
I think it's important to point out too.
And raced them.
Our
kinda
raw hide in this context means it is a fresh hide, not like your rawhide dog juice. It's the same thing. It's just at a different stage of.
This was fresh,
green,
slicker and snot, wet, hard to work with hide.
I was actually very impressed with the bark because the stuff that dried when it was tied and wrapped,
it was nice.
Was tough.
Yeah,
it was real tough. But
braided hair is a bitch.
Oh.
If you got like a daughter with long hair, try to tie her hair in a knot. Like, try to throw a granny into your daughter's hair.
It slips.
Or hell, Corinne's hair. It doesn't.
It doesn't grab.
It doesn't hold a knot.
Yeah.
Oh, brutal.
So when I braided I took all my time braiding all this hair up, giving myself you want to talk about an arthritic ache. Braiding big long strands of hair together, and then you go throw a granny in it, and it just unravels in front of your eyes. But there's a thing I read. If you take a picture, you take a deer hide. Just for you listeners out there, take a deer hide and start. So lay the deer hide out. Ideally, you'd scrape the hair off. Lay the deer hide out and start a cut in and start cutting a 1/4 inch thick strip parallel to the edge. And imagine you go in concentric circles.
Oh, like peeling
Like
an
100
orange.
feet of rope.
Like peeling an orange would be a great.
Yeah. Go around. Keep going 1/4 inch, all the whole periphery, and then come in and do concentric circles. You could stretch that. I'm gonna go out on a limb and say it. Go to the moon.
Remember, we had a guy write in and said that he used to do that with squirrel leather, and he said that you'd use that for shoelaces, and it would outlast the boots.
Yep.
No way.
Oh,
Yep.
that's a great idea.
Yeah, he did take a squirrel hide and make leather laces out of squirrel hide. And I'll tell you what, anybody's ever tried to clean a squirrel will.
Corinne, that's right up your alley.
Oh, that's totally right up my alley.
Leave the hair on there.
Oh,
Add a little flair to
Yeah.
your shoes.
Make me a
Yeah,
couple
just-
thin pieces for dental floss, bro, because what I've been using lately is not working.
That popcorn yesterday.
Would you leave the hair on for the dental floss to get a little extra,
little
out
extra
of it?
abrasion.
It's a brush and floss at the same time.
And we raced them. It wasn't like we raced them.
People got to watch.
You gotta watch.
Yes, but this comes out after the.
Don't give it all
Yeah.
away.
Yep.
Yeah, this comes after the deal, but people still need to watch.
Yeah,
but it
just
was
stay tuned.
it was a group learning effort with a race at the end. How's that?
Yeah. Highlight of my day is all day I kept thinking we were gonna find morels because of where we were.
I walked around a lot looking.
Well, did you hear what happened to me?
on the way out.
On the way out, I'm sitting in the back of a truck. I look over, just plain as day is a morel.
It grew while we were
Driving
working.
by. No, we hadn't gone in that area.
Did you
Driving
stop?
by. Yeah, Chili thought someone fell out and got hit. Stop! Stop! He jumps out. He thought someone got rolled over. We're like, there's a morel. He's like, oh my God, you guys are giving me a heart attack. We'll talk about breeding mule deer later. Oh, we use 1,000-pound animals, and then in the historic record, people talk about a bull boat that's 8 feet in diameter. But Matt Skoglund was talking about, if you really let them go, we were using hides off 3-year-old animals. If you let them go, you could get there's such a thing as close to a 1-ton bull.
Yeah, if you look at like old beef bulls, get to a point that they can't really be managed. They get so big and dangerous that they kind of just do what they want. So if you see an old beef bull out there on the range, they just get bigger and bigger. So I imagine
Bigger round.
Yeah. The muscle bulk and everything, is necks get enormous, and yeah.
The last thing I'll point out is my boat, my personal vessel, was
Did you christen it?
No. In fact, I meant to grab some of that hide for a thing I want to make, and had some Matt and Brady go back out, and they cut a chunk of hide off the boat, so as you find it laying on the bank, it's got a hole in it now. But no, it's still sitting there, right? It's just sitting in a willow patch right now.
Like it would be if back in the day.
Apparently with a hole in it. It was so stable you could cast a fly rod out of it floating down the river.
Impressively stable.
Yeah, worked very well. All right, Matt, let's dig into Colossal Biosciences. Talk about how you got started in zoo. You managed zoos.
Yeah, so I before
walk us through the career real quick.
Before Colossal started, I was I had studied biology and chemistry, ecology. I went to a master's program in South Carolina studying wetland ecology. And when I finished up there, I sort of realized,
what about wetland ecology?
So it was sort of marine and wetland ecology. I was more on the marine side, so I was studying sea turtle nesting in South Carolina, in Edisto Beach.
What species of sea turtle?
Those are loggerheads.
Loggerheads.
Yeah. And it was great. As a 22-year-old grad student, I was living on a beach for a week or two in a tent with my 140 pound St. Bernard, and just trying to walk the beach every morning to see where sea turtles were crawling, mark their nest, and study basically thermodynamics.
Boy, you painted a
of the
very
nest.
sandy tent picture.
Yeah,
right
that's
there.
immediately what came to mind.
Humid, slobbery, and then there was a dog, So, but it was great. I loved it, but I realized quickly that most of the people in my sort of path were going to work for DNR or Fish and Game or something like that. And as, when I was a kid, that was appealing. But by that point, I thought, well, I want to do something a little bit more that I own, that I can manage, and literally took a runner on a Craigslist ad and moved to Miami, Florida, and started working with bottlenose dolphins and California sea lions, and working and studying animal behavior. And so I started doing that. And that eventually led to a job working with elephants in Tampa, Florida, trying to help change the way that we manage elephants in human care, right? Because we look at the wild, we understand that a lot of these species are facing some level of extinction, and elephants have had a massive decline over the last 100 years. So one of the solutions to prevent extinction is to create captive breeding populations. And so if you're going to create a captive breeding population, you need to figure out, how do you manage these animals? How do you take care of them? And so I sort of had a job doing that at a zoo, and we were focused on that for years. And I just sort of worked my way up through the zoo system, and I was managing animal care and conservation at zoos in Miami, and then most recently in Dallas, Texas. And about that time is when I started there in 2018 in Dallas, and by 2020 COVID hit and sort of made you really sort of start to question everything. You're locked at your house, you're wondering what's happening, you really had a lot of self-reflection in 2020. And for me, I realized, it's one thing to sort of put your finger in the dam and try to prevent a leak of a species extinction. It's another thing to try to refill that well. And so I was really looking for ways that I could personally be more impactful to the biodiversity crisis. And about that time, my phone rang, and this lunatic Ben Lamb, who's our CEO, who's an absolute genius, serial entrepreneur, tons of success. He met an amazing guy named George Church, who works at Harvard Medical School and he runs the genetics lab there. Really famous for creating next generation genomic sequencing technologies, and he's sort of a legend in the genetics world. And George has had this idea around restoring woolly mammoths to the Arctic for years. And Ben, is being the business-minded one, was sort of able to formulate a business plan around that. And 2021, Colossal Biosciences launched, and they called me to come on and help with animal care, animal management, welfare, and wildlife conservation.
And was the pitch like the Mammoth project?
That was it. At that point, that's all we had.
Just make a mammoth.
Yeah, we need, if we were to make a mammoth, how do you do that? Well, there's a lot of work that requires, before the mammoth is restored, and then tons of work after the mammoth's restored. How do you take care of them? How do you eventually create sustainable populations that could go back into the Arctic somewhere? And all of those require different skills in animal management, care, and welfare, but also conservation planning. How do you go and prepare an ecosystem for a species that hasn't existed in 4,000 years? How do you go and figure out how to do this ethically, legally, hand in hand with regulators, things like that? So it's been my last 2.5 years. It's just really been off to the races. And meanwhile to that, we've quickly expanded from woolly mammoths to also Tasmanian tigers, who went extinct off the island of Tasmania in 1936, and the dodo, which is sort of the world's most iconic extinction event in the 1600s. The dodo was discovered, and 80 years later was extinct due to Dutch sailors that were introducing predators and invasive species into Mauritius. So all of those have different levels of challenges on the de-extinction side, and then I have a lot of challenges on the conservation side for how do we prepare habitats and do a lot of that prep work ahead.
But also on the why side, right?
Yeah,
it's like,
that's a big one.
You're not just doing it because you can.
It's not a
because
novelty.
It's cool.
No, we're facing this enormous biodiversity crisis, and we're missing species. I think the Tasmanian tiger's such a great example of this. And sitting here in Montana, on the doorstep of Yellowstone, you could sort of draw some parallels to wolf recovery in Yellowstone. The loss of an apex predator led to certain imbalances in Tasmania. Things like wildlife disease are running rampant today. Things like prey population overpopulation is happening, and there's wallabies and brush-tailed possums in Tasmania aren't really fun to hunt, so nobody's really regulating those populations. And so they need this predator that can come in and provide ecosystem stability. It can help remove sick and injured animals that might be spreading wildlife disease. Like if you've ever heard of Tasmanian devils are on the brink of extinction because of this facial tumor disease. And it's literally a contagious cancer. So when they bite each other, which is very much in their social network is how they communicate, they spread this contagious cancer that ends up creating these massive tumors in their face, and they eventually starve to death and die. That would have, with the right predator present, as that animal got sick, it would have been predated and would not have had the chance to pass on that disease. And so, finding solutions, nature-based solutions for how we can restore ecosystems is really the focus of what the company's doing. And we're doing it in a really fun, flashy way, like woolly mammoths. Like we came out of the gate so hot and got a lot of attention, is really fun. But I think now, I'm running around trying to help spread the word on really here's the why, because sometimes the what is so distracting that we don't get to the why. And that's been a great part of the last 2.5 years.
But I feel like on the case of the mammoth, the why is an after effect. Like the why is searching for a why after the inception of the idea.
Well,
I don't think it's fair to say that, let's be frank. I mean, the race to do a mammoth is because it'd be super cool to make a mammoth.
I think it's sort of, there's sort of two fronts to that. Or the first one is that moonshot idea of this really amazing, attractive project that's brought tons of investment, right? In 3 years, we've raised $225 million for conservation technology. In my 15 years prior, we probably raised $5 million, So the scale has been really helpful because of the moonshot aspect. And then also along the way of this amazing project, we're developing technologies and innovations that are applicable every single day to currently imperiled species. Mm-hmm. And so it really becomes this engine of innovation and investment for endangered species conservation. The other side is there is really strong evidence that shows that restoring megavertebrates to some of these areas in the Arctic, like what's happening in Siberia at Pleistocene Park, is using megavertebrates to try to re-engineer an ecosystem, and an ecosystem that's better at insulating permafrost. And so that's sort of the big idea. The scale in which to make, for that to happen in the Arctic and be this massive global solution to climate change would be, really untenable. But I think that's the idea, is that we can find, targeted areas where we can help impact those things.
You laid out how you'd make a Mingus.
Yeah.
Completely different path.
Yep.
On a mammoth.
Cloning as compared to de-extinction is easy, right? Yeah, and I think that's why a lot of people came out of the gates with the mammoth idea was always that we should clone it, and same idea with the Mingus example, but
because we have mammoth flesh and DNA and
exactly, but we don't have living flesh and DNA, and you can't clone a dead cell, right? You just can't. That's the unfortunate reality. But what we can do is we can use genetic editing and engineering tools to basically replicate. So the process for de-extinction sort of starts with paleogenomics. So what Beth Shapiro probably talked about on her when she appeared years ago.
I got to interrupt you for a minute, because as you do this, keep this in mind. We were talking about what's that marine mammal, the very small Sea Cortez?
The vaquita.
Yeah, okay. It's headed to extinction.
Correct.
But you guys are devising a plan by which you'll capture living tissue of things. You could capture living tissue of things, and down the road, de-extinction would be entirely different because you'd have captured living tissue
in the biobank.
Yep.
So let's in talking about de-extinction, there's cases where you could take a different path to de-extinction if you had the foresight to capture living tissue of white rhinos, whatever. Right? It'd be different. So we're talking right now about stuff where without a time machine, there's no way to capture living tissue.
Exactly.
Okay.
With living tissue in biobanks. So one of our biggest focuses right now is to improve biobanking throughout the world. So that means we want to go out and collect living tissues of critically endangered species. We want to create cell lines of those and freeze those down. And that is sort of the insurance policy against extinction in the future, because that gives us an ability to go back and do cloning, which is much easier than this de-extinction pathway. So a great example of just that is what's happening with northern white rhinos. I'm not sure if you're familiar, but northern white rhinos native to East Africa, sort of Uganda, CAR, DRC area. And, back in 1900, there were about 2,000, 3,000 of them in the world. By the 60s, that number was pretty stable. And by 1975, there were only 500 of them. In 2008, the last ones went extinct in Garamba National Park. But luckily, there were a few left in human care. So there's this amazing zoo in the Czech Republic that had 4 animals. They sent them to Kenya in this last-ditch attempt to try to breed the last remaining northern white rhinos. And unfortunately, it turns out, whether because the genetics of those animals were bad or they were too far down the path, they weren't able to breed. So now there's this effort using all those biobanked northern white rhino tissues to create embryos and then use southern white surrogates to make more northern white rhinos.
Yep.
And actually just this last month, we announced, so we're part of this international consortium called BioRescue that's leading this charge. Last month, we announced the first ever successful in vitro fertilization of a rhino species. So this was a southern white embryo into a southern white female, but that was the sort of proof point we needed to say, okay, now we can use the really valuable tissues. So the next step is we're going to put northern white embryos into southern white females and make more northern white rhinos. So that's sort of the conservation.
That's the Mingus model.
That's the Mingus model.
Now let's talk about the model of shit that died 10,000 years ago.
Well, even unfortunately, things like 1936, the thylacine went extinct. Right? We don't have living tissues of that. There were no biobanks back there. So what we do there is we go and find the extinct species, whether it's a mammoth or a thylacine or dodo, and we use the highest quality reference genome.
The thylacine is the Tasmanian tiger.
Tasmanian tiger, yeah. Sorry. And what we do is we sequence the genome of this lost species. And then we use, some comparative analysis to try to determine who's the current closest living relative to that species. So in the case of the Tasmanian tiger, that's this little mouse-sized marsupial called the fat-tailed dunnart. Or in the case of a mammoth, it's an Asian elephant. Or the dodo, it's a Nicobar pigeon.
Really?
Yeah. Yeah. So what we can do then is we take that genome of the living animal, we design editing targets as using the genomic analysis tool. So you sort of lay them over each other, see where is one genome different than the other, and we create editing tools to begin to edit the living species into the lost species.
What percent different, or I don't know how you express it, what percent different is a woolly mammoth from an Indian elephant?
This is a really a common question, is really challenging to answer because you and I are both human, and our genomic difference is somewhere around 99.8%, right? Or similarity. We are about 99.6% related to a chimpanzee. An Asian elephant.
I heard someone say we're about 77% related to a carrot.
Yeah, exactly. Yeah, because there's a lot of stuff in there, right? We have a lot of Neanderthal in our genome as well, right? Because we all have these common genes that might be responsible for the basis of life. But a woolly mammoth to an Asian elephant is 99.6% similar. So there's only a 0.4% difference between the two.
Okay, what about the thylacine to the mouse?
To that one is
not the mouse, but
to the fat-tailed dunnart. That one I can't recall the exact percentage, but it is much more distantly related. So
it's not in the 99s.
It's not in the 99s, no. So when we talk about editing for woolly mammoths, we're really looking at several hundred edits, which really, in the grand scheme of things, is not massive.
And then, okay, let's take this Indian elephant and the mammoth. If you just took someone who's somewhat well-informed about animals and laid the two of them out, they're going to look and they're going to point to probably the size of the ear.
Yeah, smaller ears on a mammoth.
Tusk length.
Big curved tusk on a mammoth as well.
The pelage, the hair.
Yeah, very hairy.
What else are they seeing?
They have brown fat. So they need to have these sort of cold tolerant phenotypes. I mean, they lived in a much colder place.
So I got to cut into them to find that out.
Yeah. So there's this brown adipose layer that you put in them, sort of like if you thought about blubber, it'd be similar to that. And then there's also things like physiological changes that you need. So one of the things that you have to do to live in extreme cold temperatures is you have to be much better at oxygen transfer. So we need to target things that provide those adaptations. And we have all those targeted, and the edits are happening today in a lab. Meanwhile, to that, we're doing all the reproductive side. So when the moment we have our edited mammoth cells, we'll pull the nucleus out of that and we'll put it into the egg of an Asian elephant. That Asian elephant egg then is fertilized and becomes a woolly mammoth embryo. And then from there, you use artificial reproduction, not too dissimilar to things like IVF and artificial insemination. Those are the basic tools that we start, and then we go to somatic cell nuclear transfer, which is cloning, and we clone that embryo and transfer it into an Asian elephant, or when you really want to get to the real sci-fi stuff that we're doing, an artificial womb. So we're building technologies to develop artificial wombs for these species as well. Because if you're ever going to scale a population, you'll always be most limited by how many females are in that population. So if we wanted to make 500 northern white rhinos, we would need 500 southern white rhino females. But if we had artificial wombs, the sky's the limit.
Oh, how long till this mammoth hits the ground?
So crazy.
Well, I gotta ask too, and I can see this argument coming from a guy who's sitting immediately to my left. Pushback because it's not the same, right? Oh, you want a de-extinction? Well, the animal's not the same,
Well, you'd be able to be like, that's what it looked like.
right? But it's not it, right?
Sure, absolutely. But I guess that my question would be, let's talk about pumas are a good example.
Yep.
Right. What makes a puma a puma?
Well, talking about the Florida Panther.
The Florida Panther. If I go to South Florida and I find a Florida Panther, or I come up here and I find a cougar, they're the same species, but they are completely different.
Well,
Well,
because
this
they
is a genetic
supplemented
rescue
because
effort.
this is
Supplemented out of
I'm
Texas.
glad you brought this up.
Yeah.
The Florida Panther, they got down to less than 50,
And they had extreme genetic bottlenecking issues.
and some folks said, well, let's bring in some other ones.
It's a genius
And the
move.
argument was, well, no, because we're going to lose that little special something that makes them the Florida Panther. And it says, you know what you're going to lose is the whole thing, right?
Yeah.
You can hang on to something by bringing in new animals. But if you take the path of if you take your current path, they're just going to blink out and be gone.
And it's one of my favorite examples because I think conservation for a long time has stood in its own way with this idea of perfection ahead of good, right? This whole perfection is the enemy of good. The idealism that we should have exactly what was represented in that range, which is a false narrative because we don't even know truly. We can guess really well. But I think the Florida Panther Genetic Rescue Project is an amazing example that you don't have to have exactly the same thing. You need very specific phenotypes that help it perform that ecosystem function, that helps improve the health of the ecosystem and helps restore a population. And then the environmental factors that still exist in these ranges will push that animal back into more of what you might consider 100% or pure of that species.
Yeah. And in the meanwhile, it's eating what they ate.
Yep.
It's using the
Is
landscape.
it going to
they
do
ate.
the same job?
Well, isn't that true that like the bison you guys were the hides you were working on, those bison aren't 100%.
Yeah.
Right. Like
That's a
cattle.
case where what was the expression you used? Perfection is the enemy of
good.
Yeah. That whole discussion about I think this whole discussion about cattle introgression into bison as being where it becomes like an obstacle to bison restoration.
Right.
I think it's such a distraction.
It is. And
You could line up 1,000 humans and be like, "What is that animal? Buffalo." And
Yep.
be like, "Nope, gotcha."
Yeah.
our
Gotcha. It's 0.2%
Yeah.
cattle.
Yeah.
You know, it's like, come on.
And our chief science officer, Beth Shapiro, who you know, she has for a long time studied bison genetics, and she's got this amazing grad student, Janis, who just published a paper that shows the cattle integration narrative is completely false. If you go back historically and you look at bison before the presence of domestic cattle, they had the same level of representation of what we think today is cattle in them. But it's just because they evolved from a similar
really?
place. Yeah. So there is actually very good evidence to suggest that beefalo is kind of BS.
Yeah, I've talked to her about that.
Yeah, because there's actually a reproductive block for future generations once you hybridize the two species. So it's really interesting. We don't fully understand it, but Jonas's research shows that if you go back in time, you can see the same representation of cattle in their genome that you would today. Which
From like the base of the
exactly
tree.
Yeah,
kind
they
of
sort of
thing.
evolved from
Yeah.
a similar ancestor, so they'd have similar DNA.
Yeah.
Yeah, I guess it'd be similar with how, everybody of Western European descent has some trace element of Neanderthal.
Exactly.
Yeah.
But that doesn't mean we hybridized with Neanderthal. We had a common ancestor.
Or doesn't mean we're still doing it.
Yeah, I've seen a few examples.
So let's talk about that though. I want to go back to this the set of the steps you do.
Mm-hmm.
Well, the most obvious question is, what's your guess? When does this thing hit? When does the first one hit the ground?
Science is so hard, and I hate to put pressure on our scientists, but I can because I'm not in the lab doing this, right? I'm just the stupid animal guy that talks about this stuff. We're really moving forward quickly. We just had this amazing announcement that we've been the first people to ever achieve this pluripotent stem cell line of elephants that's never been done, which is sort of an integral step along the way. So we're looking, 2028 is what we're targeting right now. I would say we have to also acknowledge that there's 2-year gestation for these. So, I would always put plus or minuses on these things, but I think this is much sooner than people expect. There's so many challenges ahead that, one step could delay us, but that's the course so far. That's what we've painted and we're on target.
And when it does, sorry, Brody, but real quick, is it a multi-step process, or does the first one hit the ground be like that's what you're aiming for?
We don't. I would say we're always going to be improving.
Okay.
Right? It's not that this is an iterative process that requires multiple steps, but it is likely that you learn something that changes the next sequence of events. Right? So as we see the first one, we say, oh, actually, maybe this phenotype needed to be tweaked, or maybe we have a better understanding of what we call genotype to phenotype relationships. And then that would inform a different type of editing strategy.
Who do you guys answer to as far as like legality? I mean, there's like obviously like ethical and moral questions that some people are going to have about this whole thing, but like where's the oversight? Like, because you guys are like international, right? Like, or is it just U.S.?
No, well, the operation is U.S. based. We also have some partners in Australia, so there's some of that as well. But with anything, especially in U.S. regulatory environment, it's a mess, right? There's so many competing forces for jurisdictional power that we don't really have all the answers yet. What we are doing today is we're working to help support the IUCN, if you're familiar with the IUCN, right?
We've talked about them. Yeah.
Right, so we're supporting the IUCN Species Survival Commission to really start to drive forward policy statements and really begin to build that roadmap. So we want to help facilitate those things, but in a third-party independent fashion so that these groups can help say, this is the exact pathway that has legal, regulatory, and ethical considerations already baked into it. And then that's sort of the gold standard that most governments are looking to help inform their domestic regulation. Here in the U.S., we're certainly subjected to things like USDA and APHIS, which has oversight over animals in human care, especially mammals, right? And then U.S. Fish and Wildlife, because we're talking about endangered species, some CITES listed, some ESA listed species. And then we have things like FDA. When you're intentionally altering the genome of an animal, technically there are aspects of that could fall under FDA jurisdiction. But what's really interesting is there's groups that have been going through this same process on the ag side already. So there are some guardrails in place. But we just want to be the subject matter expert to provide responsible regulation and move forward together. But I think Aqua Advantage salmon, and if you had you guys ever seen that? They're a genetically engineered line of salmon that are meant to be healthier in farm race scenarios. They were given genetic editing tools to essentially help them heal faster because there's so much trauma in farm race fishing, and that took 20 years to get approved. Right? So,
and is it approved for human consumption?
It just last year it received a thumbs up.
Really?
Yeah.
Is that off Atlantic salmon?
I actually don't know which salmon they based it on.
It's got to be Atlantic.
Yeah, I would think so.
All right, let me ask you this. This is the thing we've talked about. In private conversation, we've discussed this. Why, if you look at why the mammoth and why the thylacine, with the thylacine, you could kind of look and be like, one, it just happened. It just went extinct.
Mm-hmm.
Some people argue, not entirely crazy people, argue that it didn't go extinct.
True. Yeah.
And it did for a while have a Lazarus, it was regarded as a Lazarus species, referencing Lazarus from the Bible, where it was like they thought they were gone and they weren't. Another really famous Lazarus species is the black-footed ferret. It was, people thought they were gone, but they weren't. So it's so fresh. There's people thinking that one might turn up. Okay. So here you have like an ecosystem that's ready to receive it. You can point to why it went extinct. The prey base is there.
Mm-hmm.
Right? So you could put it back and it's like it just wound up missing a beat. Like that to me seems so constructive and would enjoy such public support. With the mammoth, it's like there's some argument that the ship has sailed.
It's like Brooks in Shawshank Redemption. The world just got so damn fast.
It was like Clay at the end of the live tour.
Yeah.
He's like, I was gone, but the world kept going. He couldn't reintegrate. So like, when they were around, like, have you seen all this stuff that's come out of that where they were able to look at stable isotopes in the mammoth tusk?
Mm-hmm.
And they realized how much this mammoth in Alaska was moving during its lifetime. I mean, some bitch is like in the Yukon.
Yep.
He's south of the Brooks Range. He's north of the Brooks Range. He basically traveled the length of California in a life that was, he died at what, 20 years old or something like that? So it's like, that ain't there anymore. Do you know what I mean? So how do you begin dealing with that? Like, how do you begin dealing with that? You wind up with the sort of world's most lonely animal.
Well, hopefully you won't be lonely because they'll be in a population, right? This is not a one-off novelty where you just have one of these. The focus is to really create sustainable populations with the idea of re-engineering what today is a tundra ecosystem that doesn't support a lot of biodiversity or life. Looking at what the Zimovs achieved with Pleistocene Park, where they rewilded, large vertebrates like muskox and wild horses and even bison.
How many acres is that?
It's small. I don't want to give you the wrong number, but it's not massive. Something like 800 hectares, something like that. Yeah.
How do you get around the argument though that the animals that are on the tundra now are the ones that belong there now?
Well, I think what we find is that, and there's a lot of evidence that shows this in West Africa with forest elephants, is that the presence of a large mammal like that, a proboscidean, actually opens up more ecological niches. So it's not really displacing species; it's creating more niches to bring more biodiversity. The mammoth steppe grassland ecosystem that existed 4,000 years ago was as biodiverse as the African savanna, and today it is, sort of a Martian landscape, right? It's really barren. So this idea that we could create more habitable ecosystems for more biodiversity is really compelling in a time when we're facing the world's largest biodiversity crisis. We talk about climate change all the time, and people can debate that till they're blue in the face. What you can't debate is that the extinction rates we see across the world are only accelerating. By 2050, there are some people that estimate we could lose up to 50% of all mammal species. Right? We need to find solutions. We need to begin to say, how can we support nature to be more resilient? Because nature, given time, space, opportunity, will evolve. And it's showing us that. That's why we have the amazing ecosystems we have today. That's why we have Yellowstone National Park, right? Is nature has provided something amazing. But when we continue to layer pressure upon pressure upon pressure, we're really painting nature into a corner in a place where now it cannot respond fast enough. Evolution cannot keep up. And so what we're looking to do is to provide engineering solutions to accelerate evolution, to provide nature a chance to keep up with humanity, which is really difficult. But, I think restoring ecosystems is the start of that, removing invasive predators, right? We're using technologies like genetic biocontrols to remove an invasive predator from, say, Mauritius so that it can prepare an ecosystem for the dodo is amazing. I think everybody would agree that rats, cats, and monkeys don't belong on Mauritius.
And a genetic biocontrol would be making everybody male.
Yeah, that would be one form of a genetic biocontrol. Gene drives is another form, right? So we sort of have these multiple ways that you can create a deleterious allele within an animal's genome, but also give them a biological fitness advantage. So they go into an ecosystem, they spread that allele, that gene throughout the population, and that helps suppress the population, or in some cases, completely exterminate it. So there are these amazing opportunities. They're just emerging technologies that don't have the regulatory guardrails yet, that don't have the social understanding to really support those. And so that's one of the things is we want to help socialize those ideas and help bring these debates to the forefront, because for us, it's important that we acknowledge. We don't have all the answers. We have some amazingly powerful tools, but we need to have debates about these things, because the fact of the matter is the status quo is losing. We're falling behind every year, and we need to do something maybe a little more drastic, and that's what Colossal's providing right now.
So with the case of the mammoth, like the roadmap, right? So Steve just talked about this one individual that enjoyed this giant historic range. It's just not going to have those types of freedoms. So you would try to find a suitable habitat with a lot of controls, right?
Exactly.
And also that first mammoth is going to be pretty valuable. Going to have quite the price tag attached to it, right?
You know, I think what they ought to do, and I've said this, we need to make nice with Russia again. I'm not wading into geopolitics. Let's say there's a world in which we made nice with Russia again, and we went to Wrangell Island, which was the last place they existed. They didn't blink out till 4,000 years ago on Wrangell Island.
The Great Pyramids of Giza were under construction when the woolly mammoth went extinct. Like, I think that a lot of people don't have that context of time, right? They feel like this is such an ancient thing.
Yep.
You go, no, the Egyptians were a highly civilized group at the same time that mammoths walked this earth.
Remember Trump was talking about buying Iceland? No, he's going to buy Greenland.
Yeah, Greenland.
He's like, well, we'll buy Greenland.
Yeah.
Which people tease him about, but I thought, I was like, that's a good idea. Maybe we can buy Wrangell Island.
Absolutely.
But yeah, like a situation like that, right? It's got its own fence.
I think that's how you pilot these things, right? These have to be a very thoughtful, stage-gated process of rewilding. You cannot just make a woolly mammoth and say, Godspeed, here's the Arctic, right?
Slap them on
It's
the
similar.
butt.
It's
Like, I don't know
similar.
what happened to that thing.
No, we have to talk about, like, you know, how does it start in a highly managed situation with caretakers, and then generationally that level of care is decreased and the ecosystems are broader and broader, and eventually we'll get to a point of what we would call a soft release, which is sort of this vast ecosystem. It's probably fenced or has some sort of physical barrier that allows us to say, okay, here is the experimental condition that people need to understand what's happening, and then one day you would open that gate and truly rewild the species.
And then just a crazy amount of consistent data on what's happening to the landscape because of
And that's
the
what's so
presence of the
exciting
animal.
is there's all these sort of things that have to happen in 10, 20, 30 years for this to happen. And today we're building technologies to answer those questions. So
And you also have the EIS,
what's the EIS?
the Environmental Impact Statement.
Oh, yeah. Okay.
That's why we should do it in
So,
Russia.
It's like that.
I'd pick Isla Mirada.
Like doing an environmental impact statement on it is going to be arduous.
Absolutely. But I think there's a lot of opportunity in many of these efforts, because there's emerging economies around conservation that help drive and support, sustained effort. If you were able to improve biodiversity in an area that currently has a low baseline of diversity, and you could create this African savanna-like diversity in the Arctic, you could, eventually begin to apply for things like biodiversity and carbon credits that become sustainable ways to protect nature. And it's investing in the preservation, restoration of nature rather than extracting resources from nature.
Let's take another example and talk about the ivory-billed woodpecker.
Yeah.
Okay, the ivory-billed woodpecker went extinct.
Maybe another Lazarus, right?
I'm talking to your it's gone.
Well, some
Everybody that
some
sees
folks
one-
in Cuba think it's there.
Oh, in Cuba?
Yeah.
Or Louisiana, right? That was the last one.
Anything
That
from
was-
Louisiana,
It's
you have
always
to
a
question,
pileated
right?
woodpecker.
Yeah.
There's the thing of ivory-billed woodpecker. People see it. It's a pileated woodpecker. And then I went and held an ivory-billed woodpecker. Remember at Cornell? Who was there? Was any of you guys there?
That's a
Corinne's
big
there.
bird.
Yeah, but I used to kind of like, in my mind, tease people who mixed them up. And when I held it, I'm like, okay, I'm never going to tease anyone again for mixing
It's
them
not
up.
blurry Bigfoot footage.
No, it's just like not. When I picked up the ivory-billed woodpecker, I was thinking I'd be picking up like a eagle.
Mm-hmm.
Do you know what I mean? And it was kind of like, oh, it's a delicate.
Yeah,
It's a woodpecker.
It's got a different build, but I mean, it's not this. I just, in my mind, I had them just enormous. I had them like I don't know, man. I just pictured them like giants. And you see a pileated woodpecker, and it's a good sized bird, but it's not that. And then I held one, and I'm like, okay, I see it now. I see how you'd screw this up. Like I was under, no discredit to the ivory-billed woodpecker. What I'm trying to say is I was underwhelmed by his size and felt sympathetic toward people that screw it up when they see a pileated woodpecker. But point being, it went extinct for many of you listening, it's true of me, it went extinct during your parents' lifetime.
Mm-hmm.
We know someone could take you out and show you the tree where they were last known to exist. The Singer, you heard of Singer sewing machines?
Yep.
Singer had a forest. They held a forest. It had ivory-billed woodpeckers on it. They went to do a timber cut. People begged them not to. They did the timber cut. They actually cut a tree that ivory-billed woodpeckers were using. They saw them fly out as the tree was I'm not joking. And then they were extinct. The biggest problem they have is just needing large, old-growth trees with cavities.
Yeah, and it's a really challenging one because it is reliant on that old-growth hardwood.
And I brought it up to you, being like, let's focus on that. And you talked about how birds are a pain in the ass.
Yeah, birds are
like,
real
why
challenge.
is that? Why are birds a pain in the ass?
So obviously we're focusing on birds because we have this dodo project, right? A 40-pound flightless pigeon, essentially, from Mauritius. What's amazing about that is it's also this sort of engine that's driving investment into avian conservation science that hasn't really been there so far. In the late 90s, we figured out cloning with Dolly the sheep, and now we've improved it vastly in mammals. But mammal reproduction is very different, as you would imagine, from avian reproduction. So typically we would, like I mentioned with mammalian cloning, we would take a skin cell and pull the nucleus out and put it into an egg. Well, you can't just drop a nucleus into a bird egg because it's a calcified egg. And you need to fertilize it while it's still in the body. So what you can do...
I got you.
What you can do is when you have, say, in the case of the dodo, a Nicobar pigeon egg, that is, within about 3 days of fertilization, so early incubation stage, you can actually window the egg, and using really small tools, you can pull a couple microliters of blood out. And what's really unique about avian reproduction and development is that they're sort of the cells that predate sperm and egg, we call them primordial germ cells. They're floating around freely in the bloodstream, and then they migrate to the gonads, and that's where they begin to make adult sperm and egg. While they're still floating within the bloodstream, we can pull those a microliter to of blood out and culture those, we call them PGCs, primordial germ cells, and use those to edit. And then we take those edited PGCs that are now not making chicken or pigeon, they're making dodo, sperm and egg, and put them back into the surrogate egg of a sterilized, like say chicken or pigeon line, and then those cells will migrate into their gonads, and suddenly you have this Nicobar pigeon that's actually creating dodo sperm or egg.
Wow!
The two pigeons will mate, and they'll make a dodo.
Oh my goodness!
How are they making a?
Yeah, that's what I was picturing the vent.
Yeah. So this is why one of the things we talk about is pigeons, probably Nicobar pigeons will be the genomic donor. The actual animal surrogate would be a large hen, a chicken. Yeah, well, it's not even that big. I mean, there are domestic breeds of chicken.
Oh yeah, because that's way too. Yeah, you don't need nearly that big.
No, so we could use a chicken line,
a domestic chicken that could handle an egg like that.
It just dawned on me that you have got to be spending as much time, if not more, on eradicating species, as opposed to creating. Because, think of the big island of Hawaii. You're gonna have to get rid of, introduce mongoose.
Mm-hmm.
You're gonna have to get, which they've proven that they can't, right? You're gonna have to get rid of mosquitoes,
snakes, right?
You're gonna have to get rid of snakes. You're gonna have to get rid of feral cats, which people are gonna love. My crowd is, at least. I mean, all of that has got to get done before you put this new experimental species back on the ground, right?
But they're developing tools that could be helpful for that.
Mm-hmm.
Right, yeah.
Which are also subject to all kinds of scrutiny.
Biocontrols,
yeah.
And I would say we would regionally or targeted eradications, right? Just to be clear, we don't want to just make any mongoose species but poof off the face of the earth, right? It needs to be in Hawaii, and so The habitat remediation work that has to occur ahead of rewilding or species reintroduction is as important as the de-extinction, and that's why we have such a large conservation focus of the company. That's why a big part of the job that me and my team have been tasked with is going and forming partnerships with local stakeholders, local NGOs and governments and international NGOs, so we can begin to prepare habitats. In 3 weeks' time, I'm jumping on a plane and flying to Mauritius. I'm going to go there to meet with our partners at Mauritian Wildlife Foundation to talk just about this. What are the islands surrounding Mauritius that currently have invasive species that we would need to remove? And it's not just animals; it's also plants. Plant invasives are as bad as you could imagine.
I mean, in order to begin grooming the landscape for dodos.
Yeah, you can't. There's no sense in putting a dodo, which is a ground-dwelling, ground-nesting bird, in a place that the macaque which was introduced by the Dutch. That monkey is still present where it's going to raid the nest and eat the eggs. Right? We need to remove the macaques before we introduce the dodo. So those are sort of the issues. But also the dodo had specific dietary requirements, and native plants are important. But there's been a lot of introduced plant life there. So we have to also work with the amazing work that Mauritian Wildlife Foundation has been doing to date. We're just trying to provide more tools, more funding, more resources so that we can really make a difference before our dodo. Because the worst thing we could do is sit there with the dodo and not have a place to put it, right? That's as much of a failure as missing the target altogether.
Well, the flip side of that is, in some way, having that dodo ready to go incentivizes that work in a way that there isn't currently maybe as strong an impetus to take those steps.
I'm happy you called that out, because I think one of the really amazing things about the dodo in particular, but all the species that we're working on, is this idea that they become these shining lights of inspiration and to really help focus efforts back into habitat remediation and invasive removals and things like that. So people say, well, what ecosystem function did the dodo provide? Well, it's not as critical as, say, an apex predator like the Tasmanian tiger, but it does bring interest to a biodiversity hotspot to help bring funding, to help bring attention to repairing those ecosystems. And preparing them for a dodo means also improving life for so many other endemic species of the island of Mauritius.
Well, I mean, just think of the ecotourism dollars, right? Like, so there's incentive there, but there's also going to be the battle of we can't build a hotel right there.
Mm-hmm. Yeah.
You know what's funny about the ecotourism aspect of it is, kids trip out about dinosaurs. They were so
Jurassic
big.
Park.
Well, yeah, but you'd be like, but you know what, man? The biggest animal to ever exist on Earth exists right now.
Yep.
And why are you not eager to go look at that? It's there right now.
Because it's there now.
The biggest animal to ever exist on Earth is alive right now, and everybody wants to tell me how big dinosaurs were.
Because dinosaurs
not as big
around.
as that. Not as big as a blue whale, right?
Yeah. You've kind of gotten at this a little bit, but why instead of Tasmanian tigers and dodos, instead of making them, why not make a bunch of California condors and Siberian tigers? Like now, to help them now. Obviously it's not like right now, but
yeah, I would say it's not an either or proposition for us. It is use these really compelling case studies to help drive the research, drive the investment, to be able to apply it immediately to California condor. We've been meeting with, we'll be making this big announcement about some of our focus on North American species coming up here, probably about the time this podcast drops. And one of those is also to work with Native American tribes and work in Indian country where they're already doing amazing conservation. And what's happening with California condor, and now there's reintroduction efforts that are being focused on in Idaho with Nez Perce. And I think that's where we want to begin to focus. So we have these toolkits, and there are already amazing groups working on California condor. There's so much attention on tigers, right? We can focus other places that create tools that then begin to bleed over and can be optimized back to those other species. So we're creating open source tools that are free to the conservation world. As we unlock primordial germ cell derivation and editing, we'll just give that to the California condor people, or we'll help support it ourselves.
When I'm talking about with friends about Colossal, I never use this term, but in explaining it immediately, everybody says, "Oh, Jurassic Park."
Yeah, the fact that we're an hour into this and this is the first time it came up might be a world record.
I've been
Well,
holding my
well,
tongue.
okay.
I've been holding my tongue.
I'm not bringing it up to have that conversation, but I am bringing it up to do this. We talked about Mingus. Oh, hold on. Did you want to say more about holding your tongue?
No, I just
You've been wanting to say that word.
Oh, I can talk
Randall
Jurassic
wants to
Park
talk
for
about
days.
Jurassic Park.
Well, I'm gonna.
All right,
Can I,
please.
if you don't like my approach,
No,
tell
I'm-
him not to answer it.
I'm following along. I thought we were just going to dig in.
No, we're
Jurassic
going.
Park.
We're
All right.
going right now.
I'm following.
A part of it. We talked about Mingus, where we go pluck blood from Mingus.
Mhm.
We talked about a marine mammal, an imperiled marine mammal, where you go and just get a plug out of it, like some kind of little surgical thing that you fire from a blowgun or a drone or whatever, and get a little plug a hide off them, and you got that. So living. We talked about what we have when we find a frozen, come thawing out of the permafrost, mammoth that maybe froze within hours of death or within days of death, has been frozen ever since, right? And we get it, and you'd still see like blood clots where something bit it, and you can see what it ate last, and it's still got vegetation in its teeth, right? But what happens when we get back to the T-Rex? Like, what don't you have? And what is the likelihood you'd ever find it?
Well, the first thing we don't have is an interest in dinosaurs. Just
No,
to be clear.
I don't mean you. I don't mean. I mean a collective we.
What would stop
Yeah.
somebody?
Yeah.
from-
Just a big donor comes in
No, okay, yeah. I
with
just
a
mean
private
like
island.
Yeah.
human understanding.
Of
Or
course.
like what is not?
We
Like,
don't
I
have-
know something's not there, but what is not there?
We don't have DNA.
Okay, and
You
why?
just don't. So even if typically most of the dinosaur specimens we would uncover are fossils. So those
Okay.
are rocks that took the place of a bone, right? So there's no DNA in that rock. So you can't even sequence it. If you were to find a very well preserved 65 million year old specimen, time is still an enemy. UV and temperature and bacteria contamination is still an enemy to DNA integrity. So even if when we talk about 1936, we talk about highly degraded DNA, it takes incredible amounts of genomic sequencing and so much brute force to sequence that over and over. If you think about over time, DNA starts as a single strand, just as an oversimplification. Starts as a single strand. Over time, it just cuts in half once, cuts in half twice, and it just that process repeats. So you go from maybe in 1936 we had a 500-piece puzzle that we had to use artificial intelligence and computational biology to put back in order to make that puzzle.
Mm-hmm.
If you go back 65 million years ago, it might be a 5 trillion piece puzzle. Right?
You just have dust.
Yeah, it's so hard.
Yeah.
The other side of it is we don't actually have a reference genome. So you'll hear us talk about reference genomes a lot of a living relative. One of the ways that we solve those puzzles when we have these highly degraded DNA samples is we find something that's closely related and we go, oh, so it's sort of like a cheat sheet. You know what the puzzle should look like. So you know, oh, well, the green section's up here, so I'm going to put this over here. And that's what the AI is doing and the computational biologists are working on. With dinosaurs, that just doesn't exist.
So this is not acknowledging that this is not your area of focus. I mean, this is not a thing this is not a problem that's going to be overcome.
No,
Have you tried looking for dino blood in mosquitoes preserved in amber and then
amber,
using the DNA of a West African tree frog to splice it in?
And what was that? A leucine. You give them a leucine dependency.
Dr.
Right?
Henry Wu figured all that out under the tutelage of John Hammond.
I think Beth Shapiro from our team has actually shown that ambers are a really poor preserved.
She said that. She told me that.
Yeah,
So you
yeah.
have looked
It's
into
not
it.
a good.
I
It's
think
not
she
a good way to house
actually
it.
looked into it, which is amazing. I think that's why she's so cool. But
So people can put that out of their minds.
take it out of your mind.
In the case of the
throw it
vaquita,
out.
it's the plight of that little marine mammal
Mhm.
is tied to fishing practices.
Yeah.
Oh, do you know about this thing?
Yeah.
I was so embarrassed. He was showing me pictures. I'd never even heard of the son of a bitch.
Oh no way.
I looked at the picture and I'd never seen it.
Oh, there's a lot of it's what a lot of people I can't say eat, live, and breathe, but they live and breathe that animal.
I'd never heard of it.
It's clocks
It's
ticking.
the world's
so fast.
most endangered marine mammal, and it is like anime level charisma. right?
Yeah.
It's one of the cutest things you'll ever see in your life.
But you know, like if I were in your shoes and you're like, okay, we have it in the bank, there's no point in
Correct.
in bringing it back right now
No.
until these fishing practices change.
No, but that's the beauty of biobanking is the idea is we need to take snapshots today. What is the biodiversity that exists? And not just the Noah's Ark of one by one. We don't need one male and one female. We need the largest population representation we can get. Unfortunately, with this species of vaquita, there's only 13. But ideally, somebody could go out and get all 13 biobanked. And that would give us the opportunity that if in 10, 20, 100, 1,000 years, we finally figured out all of the socio-political pressures that are driving the extinction of the species, then it could be restored, which is amazing.
But the human
that is-
apathy conundrum, right, is like if you have that approach of like, okay, we got them biobanked, these people aren't going to change.
Yeah.
We'll wait till it changes. Will it change with the absence of that animal?
Oh,
right?
I think similar to what we're talking about the dodo, it actually provides an inspiration to accelerate the change and push. We talk about the moral hazard a lot, which is this idea that if we have a technology that can mean extinction is not forever, will people care less about extinction?
Oh, like, we'll get to it later.
Yeah.
But my argument is they're already doing that, right? The level of care about the biodiversity loss is shockingly low. So we need to figure out tools to make sure that we can begin to reverse extinctions because nobody else cares. And I know that's a very broad statement, but to be fair, the amount of investment that goes into conservation is just, we should all be ashamed. The Paulson Institute did this amazing research study into conservation spending a couple of years back. And what they found is that on average, annually, between philanthropy and government spending on the conservation of endangered species, globally, we spend about $175 billion a year. They also did an estimate of what would the investment take to stop the biodiversity crisis or reverse it, and that's $900 billion a year, which really, if you think about defense spending or some other, you can find another way to contextualize that, it's not a ton of money. Stefano on my team gave me this amazing quote that every year the globe spends $480 billion on soda. Right?
What would you rather have?
Yeah, that's not to acknowledge
That's not
maybe
who
all
you
the
asked.
downstream healthcare costs, right? Of
yeah,
fructose corn syrup
exactly.
and things like that. So it just shows you that, unfortunately, the level of interest and investment is so low today that I don't think the moral hazard is a real valid argument because people do not care enough today.
If you had, go ahead, Brody.
I was going to say, if you want to get hunters interested, you need to look into the Irish elk. Put that on your list.
Yeah.
So I've got this.
I'd get behind that one
I've got
just to get a look at one. Man.
I've got this dream list going, and if you could do anything in the world, for me, it's not dinosaurs. It's ungulates. That's where I found my passion for conservation, primarily in Africa. But Irish elk is you look at a 12-foot span of antler, right? Like just insane, so tall and so big that when the forest started growing in, that's what was pushing them out of their habitat because they couldn't even fit between trees. Like just an amazing.
The
species.
shed hunting world would just poop their pants.
You'd
Wouldn't
need
need to look
tractors.
long. Let me hit you with one here because Brody mentioned why not go focus on Siberian tigers? Okay. So let's talk about Siberian tigers for a minute. How many are there, roughly? It's less than 1,000, correct?
Yeah,
I think it's way
easily.
less than that. Yeah.
So let's say you did cultivate a population, and you worked up where you got a dozen of them, cloned Siberian tigers. Could you ever get so comfortable with what you'd created that you would cut them loose and let them integrate into that population in breeding?
Yes.
You could.
Yes.
You could get comfortable that you weren't having some reticence that dude, I don't know. Maybe there's something I'm not seeing and this is going to be the final death knell.
And relatedly, are you able to fiddle around enough that you don't have concerns about genetic bottlenecks if you're bringing 12 tigers out of a lab? Like you're going in there and kind of fuzzing around the edges.
Yeah,
so that
Because if they're all gone, you talked about like de-extinction. if they're all gone, there becomes like a what's to lose. Like, you know, if you do the dodo and you want to find an appropriate habitat, you do all the work, you put dodos out, and in the end, like there's a thing you hadn't thought of, which is totally possible, and it didn't work. You'd be like, oh, we didn't have them before. We don't have them now. What can we try? But in the case of this, like with this question about the Siberian tiger, there's like, well, what's to lose is we don't know yet. There remains a chance. So by helping it, what's the risk of?
Yeah, and I think that risk has to be put in context of what is the current risk of extinction, right? Just because it is still present doesn't mean it will be present in 10 years' time. Yeah. So I think that is an important comparison. But not only am I comfortable with it, I mean, that's my dream. That's why I work here. I want to go and find these amazing programs where we can go make a difference in that way. But it's also important to note that you know, this is such a thoughtful and long process that it's not just, like I said earlier, you don't just make them and let them loose. We'd have to work in concert with NGOs, with government agencies to figure out how can we build a reintroduction program that allows us to answer all these sort of risk mitigation questions before we get to that release point. But yes, 100%, my goal in life is that before I die, I want to see an endangered species saved by this technology. Not
saved, not de-extincted, but preventing extinction.
No, both. I mean, for us, it's both. I mean, you know, we view de-extinction as a conservation tool, and I think, you know, I can see ways that we can fix habitats using de-extinction from lost species, and that we can save currently imperiled populations of animals.
Knowing what you now know, did they do the right thing on the Florida Panther, or like if we had current technologies? Would you have approached the Florida Panther question differently?
I mean, using today's tools, we could have done it differently.
And you wouldn't need to go to Texas to get them.
More expensively. And this is an amazing toolkit we're building, and this goes back to that northern white rhino example, is one of the things we're doing, and this should be right up hunters' alleys, right, is we're going back into people's private collections. We're going back into museum collections and understanding if you hunted a northern white rhino in the 50s, 60s, 80s, whatever it was, and you have this specimen, we want to sequence it. We want to go in and we want to figure out what was the genetic diversity represented of this species before it became extremely bottlenecked, functionally extinct. And now we have 12 lines of northern white rhinos. So essentially you only have 12 founders for the population. When we talk about Florida Panther, it was a couple hundred in that, and they were so inbred. So it tells you that there's a really low level. But what we can do is take those 12 lines and leave them sort of what we call wild type, and then start to use the genetic diversity information we found from those samples and edit that diversity back in. So we're actually artificially building more founder representation into the population. So that's what's happening right now for us with northern white rhino. That's our key role in that project. We're going to Mauritius to talk about doing this with pink pigeons, which are a highly bottlenecked population that went extinct in the wild. And now we're looking at where else could we apply that. So for the Florida Panther question, we could have done the same thing, or we could just go into the Western cougar and identify what parts of the genome would be most impactful back. So without taking all of the Western cougar and mixing it in, you could take pieces of it and be more deliberate or intentional about what you want to do. Obviously, that's more high-tech and sciencey, so it becomes more expensive than just translocating Western cougars. But it is a way to sort of, I think, answer some of the concerns about, are you diluting an endemic subpopulation?
Yeah.
And is there any temptation to alter these gene sequences, like to find these like Jurassic Park type ways of being like, oh, instead of like eradicating all the rats, can we make it so that ground nesting bird doesn't smell?
Yeah.
Like to where the rats don't even see the nest because they can't.
So we just announced this amazing project a couple weeks ago, I think. And so there's a species in Australia, comes from the Northern Territory of Australia, called the northern quoll, Quoll. It's a dasyurid, so it's closely related to Tasmanian devils. Years and years ago, cane toads, marine toads, were introduced to Australia as some attempt to control other invasives and just became an invasive in and of themselves, right? Cane toads excrete bufotoxin. Bufotoxin, so these are animals native to South America. Bufotoxin is a neurotoxin that kills animals that do not have a resistance to it. So when the cane toad was introduced to Australia, it really impacted the quoll because it's a perfect size and sort of niche that for the quoll to predate. And when the quolls predate on them, they eventually die. And so it's really impacting the population. So what we're doing sort of in that same light is we've identified that animals that co-evolved with the bufo toad, marine toad in South America actually have this natural resistance to that toxin. And as it turns out, it's a very simple edit. It's like one base pair change. So we just announced that we are going and making that change in northern quoll lines so that we can release those genetically edited quoll back into the northern territory. And that's amazing because it does two things. It saves the northern quoll from this imminent extinction, which almost certain extinction.
And they can start mowing those
killing
toads.
those toads.
Yeah, now they're a nature-based way to remove an invasive species. It's so exciting. And I think so to your question, we want to continue to find solutions like that.
Wow.
That's wild.
Are there regulatory hurdles on that one?
That's what I was going to say.
Right,
Absolutely.
yeah. I mean,
Absolutely.
people got to be freaking out.
I mean, we talk about
man.
there's a big fear about genetically modified
so
organisms,
wild,
right?
yeah.
And I think there is also I
got news for everybody. You're eating them.
yeah, exactly. That was going to be what I was going to say. Is I think there's this unwillingness.
Look at anybody vacation in like Florida, right? And it's like you see helicopters spraying stuff everywhere,
Yeah.
Chemicals are much worse. Yeah.
right? And you're like, do you want that or do you want?
Well, and that's
You got three choices: get absolutely eaten alive by mosquitoes, have them aerial sprayed everywhere, or you can have a genetically modified mosquito in there that makes everybody male, right?
Yep.
Males don't bite.
That would be one way to do it. But I think to your point, there's an unwillingness to acknowledge that we have been domesticating our dogs. We've been domesticating our agriculture crops for tens of thousands of years, right? Like that's sort of what we've done. That tomato that you eat every day isn't representative of what a tomato really is. That's what we've made it. But we did it traditionally through artificial selection, backbreeding, crossbreeding, things like, sort of that Mendelian idea of genetics. If we like this phenotype in this one, we're going to breed them and see what happens. We're doing the same thing. We're trying to get this gene from that target that we like, but we're just going to do it in an accelerated way in a lab. So we're still going to pull the same gene and put it in there as you might achieve through selective breeding, but we're going to do it much faster and with fewer maybe unintended consequences.
And isn't there an example of a species of zebra that the
quagga
that they brought back by doing sort of the Mendelian? You pick out
there's two efforts underway. So the quagga, which is a closely related zebra and sort of it's very phenotypically different, has no stripes. It's like more brown and spotted. And the auroch from Europe, right? There are two efforts to use backbreeding to do that, and they're making headway, and they can do so with much less fanfare and maybe criticism because people are really comfortable with breeding.
Because it looks like what people were doing tens of thousands of years ago.
But the process, when you really get down to it, if you really want to oversimplify it, is essentially the same. You're targeting very specific phenotypes in breeding. Instead, we're figuring out what gene makes that phenotype, and then we're trying to get that to be expressed in our line of interest. So we can do it much faster and
I think that's
much more intentional.
probably what scares people, though. Like without leaning too far into like the paranoia and conspiracy theory thing. Like it's like, who's making sure they're not going too far with this, right? You know?
Or in the case of the tiger, right? It's like somebody in the lab's like, but we want them a little more pissed off.
But I think that's why we invite the regulatory environment. We want to be the subject matter expert that builds those guardrails because frankly, there are very few people in the world that understand the true power of this technology more than the people at Colossal. So we need to sit down with the world leading experts in ethics and regulation to say, this is how we think we can use this, and here's how we think it could probably go wrong, right? And let's build a guardrail that keeps us on this path. Because when we have this first breakthrough, when we blow all your minds with this first restored species from extinction, we won't be the only show anymore. Right?
And then Pandora's box is wide open.
Yeah, and luckily we'll be light years ahead of anybody else, but somebody else can start to work from the same foundation that we built. So we need responsible regulation. And for me, the only way I could ever achieve my dream of putting a restored species back into the wild or preventing an extinction is to have really strong regulation that invites that type of work.
Yeah, you're in an interesting position of when it comes to policy and legislation. You're in the interesting position of needing to point out what it is.
Yeah,
like you be like hear me out. I'm going to tell you about a thing we're figuring out how to do that you're probably not aware of, and then I'm going to tell you some things that you might want to do in order to get your hands around the thing I'm going to tell you about.
Yeah.
You know?
And that's why if you've looked into us a bit, one of the groups that's invested in Colossal is the venture capital arm of the intelligence community here in the U.S. because they want to understand more of that. So we can work in concert and show them sort of what are the capabilities of today, and so that's why they've invested in us, because they understand that it's also important to national security that the United States leads this effort. If we're not doing it, somebody else is doing it. We better be the best at it.
Yo.
Yeah, you may have put a chimp into outer space, but you haven't put a colossal chimp into outer space.
Because if our enemies come out with a psychic war elephant,
right?
They're gonna look to you and be like, "Well, how come I don't have a psychic war elephant?" You know what? You'll be pleased to know. I just thought of how to tackle the dinosaur deal.
Oh, great. Let's hear it.
Check it out. Everybody now knows that, like, birds, people are like, well, dinosaurs didn't really go away because some of them became birds.
Yeah.
Somewhere deep in that bird's blood. I mean, deep.
A turkey, specifically.
Turkey.
Yeah.
Probably. I'd start with a turkey.
Maybe a crane.
Yeah,
Somewhere deep in that turkey is probably the secret of what you're looking for. Deep in his blood.
All of Steve's best ideas begin with everybody knows X, but
deep down in his blood. I mean, the blood in the middle of his heart.
Yeah, we might have just been looking in the wrong part of the anatomy. Yeah.
Is probably some clue.
Have you seen a Watson? It's a South American bird. It looks like a tiny velociraptor.
Oh, is it close?
Yeah. That might be where I would
even
start.
better than a crane?
Yeah, that might be where I'd start. They're terrifying looking. They have little claws on their wings.
Oh, they do?
Yeah.
ooh,
I like the fact that nature has sort of put up a roadblock, according to you, that is going to hopefully prevent us from doing what you're talking about too far back.
Too far back.
Yeah.
Mm-hmm.
Or that it just, and to me, in a way, like I've said this for a long time, and I get a lot of like frowns and like weird looks when I say it, but extinction, if it happened way back then, we lost all these species. It was a crazy place. It was a very diverse world. And then all of a sudden, like, something hits the earth and it changes. All the shit goes wrong. We lose everything. But look, right now, or 100 years ago, wow, we have another very diverse, cool place. And there's nothing to say that as bad as we fuck it up in the next 500 to 1,000 years, and we are gone, that 10,000 years after that, it won't be another beautiful place.
Yeah. I look forward to us all being gone. Humans all gone, and then let millions of years go by, and then come back and look.
It'll be cool.
Like, oh my, like, good Lord.
Yeah, I'm certain that
They're going to put you in the biobank so you can come back.
So I can come back and
you
look.
and Ted Williams.
Just your head, yeah, Ted Williams style. I'm certain that in nature and Earth will survive. It just won't be the nature of Earth that we know and we're pretty attached to, right? So it'd be nice. I think you're a little optimistic to think that civilization will last 500 or 1,000 years, though. At this rate that we're chasing down biodiversity loss, people think that biodiversity loss is only about the intrinsic value of nature. It's important to your food security, your health, everything. Without a balance in nature, humanity will not thrive. That's why we got people looking at figuring out how to go to Mars.
Yeah, I think that, just our increasing understanding of the microbial structure of soil.
Mm-hmm.
I don't know. We talked about Aldo Leopold the other day.
Yeah.
His idea of someone that doesn't really understand a watch, looking at a disassembled watch and being like, well, I don't see what good this part is. Right? It's not obvious to me what that part does, and flick it out, and then later be like, damn it.
I think that's a brilliant
That
analogy.
was the part that does the...
And we do that every day when we say, commercial fishing is overfishing our seas, and we're seeing different, sizes of fish or different populations of fish out there just because of industrialized fishing. We talk about when we are even doing, development for human housing. We're just digging up pieces of land that we go, well, nothing that we know of today was important there. Great example to that was there's this small lizard from Australia, again, in Victoria, called the Victorian grassland earless dragon. It went extinct in 1969 and it never seen again. And then one guy was digging up some housing, some land in Victoria to put up a housing development, had to do an ecological survey, and they discovered the Victorian grassland earless dragon.
While they were destroying its
While they're
last
destroying-
remaining stronghold.
Exactly. What's great about that is our partners at Zoos Victoria in Australia called us and they said, unfortunately, the Australian economy is not strong right now with all the stagflation issues down there. And they said, unfortunately, there's no money to save this animal. We ended up we ended up funding it. We ended up supporting all the genetics and genomic research, and Zoos Victoria has done an amazing job. Maybe one of the best species recovery stories I've ever heard of. They're the most prepared. They thought, one day somebody's going to find this lizard. So they went and found a closely related lizard and perfected its husbandry. In the first year that we put that animal at Zoos Victoria, they laid eggs, and now we went from 16 animals to about 70 or so. Yeah, so I mean, just amazing, right? Absolutely incredible story, and I think that's just goes to show you that just because things aren't obvious, there's a lot to nature that we don't understand, or that we just that you kind of miss, and could have these insane ripple effects.
Well, that was great. Thank you for coming on.
Well, thanks for having me. I mean, this is you got a lot of fans at Colossal. I'd be remiss if I didn't give a shout out to our head of animal husbandry, Steve Metzler. He's the biggest fan of you guys. So he was jealous he couldn't be here, but we really appreciate the audience with you and getting to share a little bit of what we do. We hope we have some exciting updates for you coming up.
Yeah, I wanna make my final clarification here. Like we joked a little bit and had some laughs about things, right? But I do think that when we had dinner last night, we talked about that I used to I had the wrong idea that I always thought people justified the space race by pointing to Teflon, and then someone pointed out Teflon didn't come from, I thought it came from our efforts to land on the moon. Either way, I was bringing up this idea that you chase a thing, right? And maybe it's not clear the why. We have this desire at a time. We have this desire to go to the moon.
Mm-hmm.
Right. And it's kind of like, well, what are you going to do when you get there? And it's an open question, but it leads you down this path. And for us, it led down this path of eventually satellite technology, internet, whatever. It opens up all these things. And I do really appreciate in the conversations that we've had, I do really appreciate that there's this kind of like North Star idea that's very arresting. About like that we would make a mammoth, right? We would de-extinct a mammoth, and I appreciate that for its like lunar shot appeal, right? But the way in which that, like looking at that North Star, the way in which that has created and will continue to create strategies and technologies that would be like applicable to real world current problems is like it's noteworthy.
Yep. I totally agree.
I'm supportive of the pursuit. Mostly, as much as I'd love to see a mammoth, I'm supportive of the pursuit because of the all the implications that you discussed about ways in which you can be currently helpful on real problems of species blinking out.
Absolutely. The journey is as important as the destination in this case, right? We are doing amazing things along the way. If we ever get to the point where we've had so much success that your concerns about the destination come into play, we've hit such a home run that we have made such a difference to the natural world that I think people will really understand, in retrospect, why this pursuit is so important.
When it comes time to find out the regulatory structure on mammoth hunts, I would appreciate if you guys came and talk to us.
Yeah, definitely. Hopefully,
the tag draw system.
Governor's tags.
No hunter's orange necessary.
right. Matt James from Colossal Biosciences. Thanks for coming on, man.
Thank you so much, guys. Appreciate it.
Thank you.
Well, it's a fresh set of eyes. We'll always find more beans crawling in the garden on your hands and knees. Well, I don't mind being the one to tell you you done wrong. But come on, baby, there's not tonight. So listen to my song. Well, honey, I'm a hot puss in the pot with you. There's nothing that I can do. So feed the flame, honey, I love you. I'm your puss in the pot. I'm a hot puss in the pot with you. There's nothing that I can do. So feed the flame, honey, I love you. I'm your puss in the pot. Oh, I'm the puss in the pot. You don't believe me, honey, I'm your puss in the pot.